Welcome everyone to another CTC Software webinar. My name is Sean Zerbis, Technical Evangelist at CTC, and today we're going to bring you another special guest. We have Stephen Bunker here with us today to talk with us about the Mechanical, Electrical, Plumbing Productivity Pack, specifically focusing on the electrical portion of the Productivity Pack. As always, with all of our presentations, we encourage you to leverage the questions window. We will try to answer those questions in line, and in some cases, I might jump in and interrupt Stephen to have him answer one of the questions if I don't have it myself directly. And also, as always, this webinar is being recorded. So if you have individuals in your firm or partners in industry that you want to see this, by all means, share this with them after the fact. And without much further ado, Stephen, the floor is yours.
Hey everybody, thanks for joining. My name is Stephen. I am one of the developers of the MEP Productivity Pack, specifically focusing on the electrical side of the pack. I'm glad you could make it to our webinar. I've got one slide for you, and then we're going to switch over to Revit. If you're here, you probably know what the MEP Productivity Pack is. It's a content library for MEP design within Revit. It includes a starter project that can be used as a template for starting up your own new projects. It has a sample project in order to demonstrate the capabilities of the product. It has a family library and supporting files like a user manual, shared parameters files, and a few other files for your use. The purpose of the product is twofold. For one, it is a get started now package for MEP firms that are completely new to Revit. It has everything you need to get started from nothing. Even the user manual serves this purpose, since the user manual doesn't just cover features that are unique to the product, but also has some information on how to do MEP design within Revit more broadly. The developers of the pack, including myself, are actual engineers that use this product for their own production work in their MEP firms. And so the developers know what they're doing from a design perspective. And the other purpose of the pack is to provide advanced features and content, even to firms that have established standards for MEP design within Revit. Not only are the developers actual engineers, they're also experts in the use of Revit for MEP design. The pack contains features that you're not going to find anywhere else in the industry that really streamline the MEP design process in lots of ways. We have put thousands of hours into development of this product so that you do not have to put that time in yourself within your firm. In this webinar, I want to give you an overview of the electrical content specifically that's in the pack. You can purchase the product as a whole. You can buy mechanical, electrical, plumbing all at once, or you can buy just mechanical plumbing or just electrical. Last week, we had a webinar covering the mechanical portion of the pack. This week, this webinar, we're covering electrical. Next week, we're going to have a webinar covering the metric version of the pack, which is specifically marketed to our Canadian customers. So if you have an interest in the mechanical, there is a recording of last week's webinar that you can find on CTC's YouTube page. And if you do anything in Canada, be sure to join us for next week's webinar, where we're going to talk about the features that we have for the Canadian market. When the pack is sold as electrical only, we often call it the Electrical Productivity Pack, or the EPP. So if you hear me referring to the EPP in this webinar, you'll know what I'm talking about. It's just the electrical portion of the pack. In this webinar, I want to help you decide whether the EPP is a good fit for you and your firm. I'm going to try to look at the sample project as a whole, probably spend 20 to 25 minutes looking at the overall project. And then I want to spend another 20 minutes looking at some specific family content and features. I'm going to focus on what is in the pack and what it can do rather than how. Just for the sake of time. If you the how is all in the user manual, so I'm just going to be talking about the what. If you want more information than we have time to cover today, on CTC's website you can download our user manual, It's over 300 pages of information on what is in the pack, how to use the pack, and also has dozens of tutorial videos so you can actually show how everything works in the future. We want to answer your questions. So if you have a question, like Sean said, put it in the Q&A box. Sean will field those. And if Sean, if there's any that you think would be good for me to answer before I move on to another topic, you're welcome to interrupt me, and I'll try to answer on the fly.
Certainly will do.
We will save them to the end. So I'm going to switch over to Revit now. Give me a second to. Okay, and you see Revit now, right, Sean?
Yes, sir.
Perfect. Okay, so we're going to be in Revit the rest of the time. This is the sample project. When you purchase the product, like I said, you get several things. You get a sample project, you get a starter project. The starter project is basically the sample project with all the sample material stripped out of it, so you can start your own project from it. This is a full design within Revit. You see we have an actual building. There's some mechanical elements in here. In this particular view, you can see some site lighting. The purpose of this is to demonstrate the capabilities of the product in a real world design. And so that's what we're going to be using. I'm going to more or less use the project browser as our tour through the sample project, just to give us some structure. I'm going to go through all the way down through the project browser, taking a quick look at the overall project, and then we'll circle back to some specific content and features. If we take a look at our views, you're going to see that we have mechanical and plumbing all in here. The pack is designed for electrical, mechanical, and plumbing to all work within the same model. And that's why we're seeing it all in here. If you buy just the electrical portion of the pack, or if you just prefer to have mechanical linked in via a separate file, most of the stuff will still work. The only thing that won't necessarily work as smoothly as some of the coordination workflows. When you have mechanical working in the same project with electrical, then some of the electrical schedules can pull directly from mechanical in ways that's just a little bit more streamlined. And we'll look at that a little later. But if you buy just electrical, most of the features will still work. If you are using the pack, the project with mechanical in here, you don't need to see all of these. And I'm only interested in electrical. So I'm going to come over here and filter to just electrical. And we'll see that it's going to hide everything that I don't need to see being an electrical designer. All of our views are organized by view classification. So up here we have analysis. Revit's analysis features are not are rather limited for electrical, but we do have a basic lighting analysis feature built into the product that you can take a look at on your own later. I'm not going to look at it right now. Construction documents is where all of the views live that are intended to be placed on sheets. So we have them divided into disciplines. Let's open up, say, power level 1. And this is a view that's intended to be placed on a sheet. So what you see is what you get, except if you print grayscale, of course, your colors won't print. Yeah, so power site, symbols, we'll talk about the symbol legend a little later. Systems is where we keep fire alarm, and of course lighting would be under here. Drafting views. So we've got a ton of details in here for your use. If you're at an MEP firm, I'm sure you have your own detail library, but here also is a detail library for your use. While we're looking at this, I want to skip down to schedules and show you our detail index. So if you're looking for a particular detail, this is a schedule that basically lists all of the details that are in the project. You don't have to rely on the name of the view if you know that you're looking for roof edge detail. You can find it in this list and not have to rely on just the name of the view and have to sort through where all of these are. So this is just a neat tool that we have. If it's placed on a sheet, you can also see what sheet it's placed on. If you load your own details into the project, as long as you classify them, the view classification the same as these, it will also appear in this list. So just a quick aside. Going down through here, coordination is just what it sounds like. It's where we keep our coordination views. Project setup also is what it sounds like. If you are familiar with Revit, you know that in order to set up new files with a linked architectural or structural model, you'll typically have views created so that you can copy monitor levels and grids, and that's where those views live. While I'm here, I'll show you one neat thing we've done in project setup. All of our views, first of all of our views are associated with view templates. So that provides consistency across all of your plans to make sure everything looks exactly the same. If you buy electrical only, the mechanical plumbing views will be stripped out. But if they're all here, all of our electrical views start with an E underscore, and this would be a G underscore because it's general. So you can ignore most of the others. So it's easy to navigate. There's a few dozen view templates here for your use, and they're all being used in the sample project somewhere. All of our views also are associated with scope boxes. If you don't know what a scope box is, it's a quick and easy way in Revit to make sure that all of your views are cropped exactly the same, so that when you place them on the page, they're all in the exact same position, they're all the exact same size, they all show the exact same information. And the way that we've done that is we have our scope box already set up in here. And when you read the user manual on how to set up your own project, your own new project, all you have to do is move this scope box and resize it to encompass the building that you're working in, and all of your views crops will update automatically based on that. We also have a couple of scope boxes set up for if you have, say, a stacked telco room or stacked electrical rooms. You can set up these scope boxes around those stacked rooms through the building, and all of your telco or electrical room enlargements will all be cropped exactly the same to show just what you need. That's an example of the kind of automation that we've tried to build into the pack. If we didn't have this, you would have to create the scope box by yourself, which isn't that hard, except then you would have to go to all of the views that you have set up and manually associate the scope box to each one of those views. And that can be a tedious process. Here, our scope box, our views are already associated with these particular scope boxes, and you just have to edit the scope box. So that is a time saver that we have built in. Working views is where we tend to actually work in the project. So if construction documents are the views that are set up on the sheets, the working views would be where we actually work. And I'm going to show you exactly what's in those working views a little bit later. But for right now, it's just suffice it to say that it's one of the views that's here. We keep going down through the project browser. Legends. We don't have any legends in the sample project or the starter project. If you're familiar with Revit, you know that legends have some significant disadvantages in Revit, and so we're just avoiding them altogether in favor of some other workflows that work a little bit better. Schedules. You may know that a couple of upgrade cycles ago, Autodesk graciously granted us the ability to group and filter schedules, like most of the rest of the project browser can be done. That's great because we did just have a great big long list of schedules that you may remember. We've taken full advantage of that feature, and we have grouped them into mechanical, electrical, and then general. General would just be where we keep things like sheet lists and a few other things. Electrical, we have some fire alarm device schedules. This general category, we already looked at the detail index. We have some cost estimating features built into the electrical side. Notes, electrical sheet index. Lighting fixture schedule is one that's going to be used on most projects, I would assume, on the MEP side. Power, we have some design aids. Let's take a look at one of these to give you an example. This is a circuit overload check schedule. So this is a schedule of all the circuits in the project, and it takes the how heavily they're loaded and compares it to their rating, and it gives you a percent loading. And anything that's over 80%, it'll turn red for your review. So here's a 17 amps on a 20 amp circuit. That's an 85% loading. Maybe fine for this application, but it's creeping up there, so it's turned red for your review. Here's one that's obviously a problem. 172 amps on 20 amp circuit. So probably that circuit rating needs to be adjusted. So This is an example of some design aids that's in the project for your use. Motor list. The motor list is what we call our equipment connection schedule. So where we list out all the mechanical equipment that needs power connections. I'm going to come back to that a little bit later to show you how that works in some more detail, because that gets into some of the mechanical electrical coordination workflows. So we'll come back to that. If we keep scrolling, panel schedules. These panel schedules are for the panels that are set up in the sample project. So if we go back to our power plane, we got our electrical room over here. These panel schedules will not be in the starter project because you'll place your own panels and put them, create schedules for those. We do have several panel schedules templates set up. Most of these are pretty typical panel schedules. There's not just pretty typical, but there is one that I'd like to show you, and that's our switchboard schedule. I think that's on this sheet here. Yeah. So this is a switchboard schedule that we have in the project. Switchboards can be a little difficult to model in Revit because switchboards are actually it's actually an assembly of multiple pieces of equipment. You've got a main section where the power comes in, then a horizontal bus that runs through the entire switchboard, and then each individual section will have vertical buses. And depending on the complexity of the design, each one of those buses may need to be scheduled and a load summary provided for them separately. Revit can't really do that natively. And so we have developed a way of doing that. This is a schedule that is for the overall switchboard to give some information. This project has one distribution section on the switchboard, and this is its schedule. And you can add additional distribution sections to this schedule as you need. And then we have a load summary for the overall switchboard. So that's just an example of a feature that you're not going to find in Revit out of the box, but we have provided in the pack. Next, reports. We don't have any reports for electrical. That's for energy analysis on the mechanical side. So there's a couple here, but they're not for electrical. And then sheets. We have a starting view. So when you first open the project, it's going to come up to this. I like to call it a splash screen. If it'll open. Sorry, it's being a bit slow. For this starting view, it shows project information. You can put your logo here. There are some schedules here that you can use to configure some of your families. These are mechanical, and then this is we have a method of doing phasing that can do a little bit more than Revit can do out of the box. By phasing, I mean existing demo new type stuff, renovations. So this is our splash screen, and this is where our projects typically open up to begin with. You can leave notes here for other designers, etc. Other than that, we have our sheets already set up. These are all of our electrical sheets. These that say not used, those are here because we're working in the sample project. Those will not be there in the starter project. So here's our title sheet. You can see that when it opens. So we have abbreviations, symbol legends, notes, the sheet schedule. So this is all here. I'm sure that you will need to customize it for your particular firm, but this is just an example of how it can be, and you're welcome to use anything that's here that's already here. Title block is here that you'll probably replace with your firm's title block or with the architect's title block that you're working for. And then we have sheets set up with views already on them. And all the sheets are set up over here too. These are the sheets that you would actually use for the starter project. Of course, each sheet will need to be adjusted for the particular project that you're working on. But by having the sheets already set up in the starter project, you can at least skip the step of creating the sheets to begin with, which can be a bit of a tedious process. And continuing, families. So we have a few hundred electrical families across all the family categories for electrical. So for example, electrical equipment is probably the most commonly used one. We see all the electrical families, equipment families that are here. Electrical fixtures. So families and then groups. We do have some groups that we use on the electrical side for pole lighting in particular. I don't think I'm going to have time to cover that today unless we have some time at the end. Somebody wants to ask a question about it. But we have a workflow that makes pole lighting, site lighting a little bit easier using some model groups. If we don't have time to get to it, then there's a tutorial video in the user manual you can take a look at. So that's the overall project. Before I go to specific content, does Sean, has any questions come through we want to get at? And I'm going to switch back over here.
No, I think we're good for now.
Okay. So that's the overall project. I'd like to look at specific content now. And I'll just probably go through family categories. So let's start with electrical equipment. These are all the electrical equipment families that are in the pack. So we should have what you need in the pack for your particular application. I'd like to look at one feature of electrical equipment. I'm going to hide these labels so we can see what we're doing a little bit better. And I want to look at, these are some panel boards. As you can see, well, I can't select them because I'm not in the right design option. There we go. As you can see, our clearance is built into these panel boards. The clearance depth is calculated according to the National Electrical Code. So we have checkboxes over here for our working conditions, condition 1, 2, and 3, based on that table in NEC 11026. By default, when you first place any panel, it's going to be set to condition 3. So this is a 40-volt panel, so this should be 4 feet based on the table in the code. We can change it to condition 2, and that should change it to 42 inches. Or back to condition 1, and it should match these 208-volt panels at 36 inches. So that is calculated for you. You don't have to enter it manually. These clearances also slide back and forth along the panel. So if your panel is up against a wall, your clearance isn't going to be clashing with the wall. You can use this grip here to slide it, and it will slide. Let's take a look at these in 3D. Yeah. I'll change it to shaded so we can see a little bit better. These clearance objects are actual 3D geometry in the family. And you see we've got dedicated space up here too. The height of this dedicated space is adjustable. So code says, I think it's 6 foot, or to structure, whichever is lower. So they are 3-dimensional objects so that it will actually generate clashes. So if mechanical tries to run a duct through the wall above your panel board, then you'll know when you run a clash detection. You don't have to just rely on actually finding everything yourself. These clearances also can be turned off. So let's turn on my temporary view. And they are generic models, so I can turn off clearance. So if you don't need to see them, if you're working in a 3D view or the architect doesn't want to see them, you can turn them off separately. So those are clearances in electrical equipment, and you'll find that most of the electrical equipment works pretty much the same way. Let's look at electrical fixtures now. I'm going to go over to this restroom because we have some built-in labels. These are two receptacles for the restroom, GFI, AC. So AC is our symbol, our code for above counter. And I'm sure you know what GFI means. The symbols and the labels are adjustable. And I'll show you what I mean by that. Let's take a, actually, before we talk about the symbols, I want to show you our detail level view. So I'm going to zoom in. I'm going to look at this one in particular right here. I'm going to change my detail level to, oh, I got to turn on temporary view. Okay. I'm going to change my detail level to fine. And you see now that when the detail level is set to fine, we see the actual geometry of that receptacle in the wall. And when we set to medium, we see the symbol. A lot of content that you may have worked with in Revit, if you've used Revit before, uses view orientation to control that visibility. So if you know how families are made, you can hide geometry based on the particular direction that you're looking at it. The problem with doing that is you can't see the geometry in a plan view if you ever want to, and there could be situations where you want to. So instead of doing that, we've opted to control visibility of both the symbol and the geometry based on detail level. So if you're set to fine detail, you're going to see the actual device. And if you're set to either medium or coarse detail, you will not see the device, but will rather see the symbol. So what I was talking about with the symbol being adjustable is you can move this symbol back and forth along the wall without the actual device moving. So that device stayed put right where it was, but the symbol moved. And I'll give you an application for that. I'm going to hide this wire here. Let's suppose you want to switch and a receptacle beside each other. So this is a light switch. I'm going to place it on the wall, but I'm not going to see it because my lighting devices are not visible. So let me turn my lighting devices on. There we go. And I didn't get the hosting right because I couldn't see what I was doing. Okay. So let's say you want this receptacle and this switch to be right beside each other. And so you place it like this with this receptacle and the switch. It certainly looks like it's right beside each other. But then the architect is doing their architectural elevations and they see they're not beside each other at all. So they say something to you about it. And so you move your devices right beside each other to make your architect happy. But then in your plan, your symbols are right on top of each other. You can't see what you're doing. So I can grab this symbol and I can just move it down. And so this clearly shows both symbolically and in your architectural elevations that the devices indeed are side by side. You can also move the device away from the wall. So like so. This will move the symbol away from the wall without moving the device away from the wall. And then we have built-in labels. If you have worked in Revit, you know that if you try to tag something that doesn't have the data in the tag parameter, it'll show a question mark. It'll just have this big question mark. And so the tag all not tag command can be difficult to work with in Revit when you're working with electrical fixtures. So we have the option to use built-in labels. These labels are built into the family itself, and you can move these labels around to to where they need to be. So you're going to find that most devices in the family or in the pack works this way, where the symbols and labels are adjustable like this. Let's see. Working views. So we skipped working views. And I'll show you what it works, and I'll use this restroom as an example. If we go to our working views, floor plan, power, level 1 power plan. So this is the power plan working view, and you can see the difference. We have a lot more information in the working view than we have in the sheet view. So for one, we can see all of these lighting fixtures and mechanical terminals and fire alarm here. So you can work in this view and see what you're doing a little bit better so that you're not conflicting. If you're trying to, you can't see the switch, say a light switch where you want to place a receptacle or vice versa, you can kind of see what you're doing a little bit better. I actually prefer to work in the sheet view, and the reason is one piece of information you don't see in a working view is any annotations. So for example, we have wires here. I've got one wire hidden, but I've got wires and wire tags here that I can't see in the working view because annotations are view specific. So let me reset my temporary view, and I actually prefer to work within here but apply a temporary view template so that I can see everything at once. So that's nothing unique to the pack. It's just a tip and the way that I like to work. This is a power plan working view. So you can see that my power devices are full line weight and in color, and everything that's not a power device, such as this light, or these plumbing pipes here are a light color. They're for you to see, but not to so much so that they're distracting. Let's talk about the colors. The colors represent circuiting. We have some filters set up in here to indicate whether these devices are circuited or not. So these two devices are on the same circuit and they are circuited, and we can tell that by the color green. Of course, we can also tell that by the wire and the tag, but if you didn't have that, then it can be difficult to just quickly look at the overall plan to see what is and isn't circuited just based on wires. If we select this circuit and say disconnect the panel, they turn magenta. So green indicates circuited and connected to a panel. Magenta is circuited but not connected to a panel. And then if we just delete this circuit entirely, they're going to turn red, indicating that they're not circuited. So let me recreate that circuit. Well, I don't need to because I'm in a local model. So you can just quickly look at a plan and see everything you see should be green. If it's not green, there's something wrong with it. You should take a look at it. We have several circuits here that aren't on panels for some reason. This switch isn't circuited, but that's because I just created it for demonstration. So that's an example of how our working views are set up. We have working views for all the disciplines. So this is a power plan, but I can, for example, change it to a lighting working plan. And all the lights will turn color and full line weight, while all the power and other devices like these two receptacles we were just looking at are now a thin line and dashed. So this just, they're already set up. You don't have to set them up. You can just use them as you will. All right, let's talk about mechanical coordination. Let's go back to this. Let me reset this temporary view because I'm going to use it. And let's go back to our motor list. Like I said, our motor list is what we call our equipment connection schedule. I'm going to delete this because I'm going to place it again to show you what it is. Our equipment connection schedule is, I'm sure you all know, you do electrical design. It's where we list all of the mechanical and plumbing equipment that needs power connections and all the information in them. If you are working in the same model as mechanical, and if mechanical and plumbing are using the productivity pack instead of your own content, then the information in this schedule will come directly from their equipment instead of you having to manually duplicate it. If you're linking it in from another model, you will have to manually duplicate most of their information because just not all the information we need comes through the link. So let me give you an example. Instead of messing with their equipment, I'm going to place a new device. This is what we call a motor equipment family, and I'm just going to place it right here. So this is one of the families that you might use to represent mechanical equipment if you're not working in the same model with them, if they're linked in. And so I'm going to use this as a stand-in for mechanical. And let's take a look over here in properties. All of the load info for this family is here in properties, and these values here is what actually appear in this schedule. But before we look in the schedule, I'm going to show you just in the properties palette. First of all, we have a motor power input in horsepower. So this is a 480 volt family, and so let's say this is a single motor that's 10 horsepower. Oops. All right. This looked up a 10 horsepower motor, 480 volt motor from the NEC tables at the back of Article 430. And it looked up the FLA and it put it right here. So 14 amps, if you look in the table in Article 430, you should find 14 amps for 10 horse at 480. And then from that, it will calculate all of these other values. So it looks like our power factor is set to 1. So our real power and our apparent power is equal here. There's a power factor value right here that you can change if you need to. It is calculating minimum circuit ampacity based on 125%, and it's suggesting overcurrent device. This is just a suggested or overcurrent device. If you're working on this, you should know that all of these values can be overridden. So if you don't like 25 amps for this motor, you can override it to say a 20 amp. This in particular also does linear interpolation. So for the three-phase table, I think it skips from 10 to 15 horsepower. So if I put in, say, 12, yeah, 14, and now it's 16.8 amps. And you should find that that's a linear interpolation between the values between 10 to 15 amps. So this will do that for you, and you don't have to do that manually anymore or using your spreadsheet that you have surely created for your own use. If this isn't motor equipment, you can just leave this blank. And let's say you know the load, let's say 25 kVA. This will calculate everything for you and suggest an overcurrent protection, which again, you can override any one of these values. If you override the values, it might not make sense anymore. So if you have 25 kVA, that is equal to 30 amps at 480. You can override this, but it may be a nonsensical input, so you just have to be careful with overrides. All of these values here that are in gray you see are calculated are what is in our equipment connection schedule. So FLA, MCA, MOCP. These are all here, and this is the schedule that is intended to be placed on the sheet. We have where the equipment is located, the ID, we have the circuit number here, and then we have information on starters, disconnects, controls. That's all here. Most of this stuff in this schedule, though, is actually not editable because you realize these are calculated values from over here. So instead, we have a working schedule. We call it input values. And you see we have a whole lot more information here. First of all, we have this little yes, no checkbox. You notice there's a lot more in this list than there is here. And that's because when you are working with mechanical, there is a parameter that they can check in order to indicate that it needs electrical coordination. So if they check this box, it will appear in your schedule and it will appear on your plan. If it is a piece of equipment that they're placing but doesn't have power for whatever reason, they could just make sure that box is not checked and you won't even see it. You don't have to know about it, so it doesn't have to clutter up your stuff. We have some QC features, including this is a place where mechanical can put a link to the spec sheet for the equipment that they're working on. And then these blue columns are input values. So these are the input values that we were just looking at. Yeah, these are all the input values for everything. So generally, you would work in this schedule and then just review this schedule to make sure that it looks right to be placed on a sheet. So that's an example of our mechanical coordination workflow. Again, this schedule still works exactly the same. This is the device that we just placed right here, except if mechanical is not in the same file, you'll have to place this device and edit all this, basically duplicate all this information from what they have. So that shows the value of working in the same model with mechanical, if at all possible. So that's our equipment connection schedule and mechanical coordination. I'd like to show you something on fire alarm. So we've not talked about fire alarm yet. Our fire alarm is in our systems plan. So if we go to level 1 systems, let's go back to this bathroom that we've been working in. Fire alarm devices work the same basically as the electrical devices in that the symbol and the labels can move, are adjustable independently. In this particular one, this is a tag and not a label. So the labels are turned off here and this is tagged. That's just a different workflow that you can choose to use if you wish. One thing on fire alarm I want to show you, so this is a strobe, it's a 15 candela strobe, and it's obviously intended to cover this entire restroom here. Over here in options, we have some coverage options. This is 15 candela, should be, and so this 15 candela checkbox is enabled. We can check this coverage on box, and you're going to see a hatch showing the coverage area for a 15 candela strobe from NFPA 72. I think 15 is 20 by 20, so that should be a 20 foot by 20 foot box. You can turn it on, quickly see, yeah, that clearly covers the bathroom, so I'm good. And you can turn it back off. So all of our strobes have that built in. That's just an easy workflow for you to lay out your fire alarm plans. Let's look at lighting. Under ceiling plans, lighting, let's go back to level 1. We've been looking at level 1. This is the sample project lighting plan. Lighting got a pretty significant revamp in the latest release of this product with lots of new features. And so we might spend a little more time on lighting, looking at some of the new features. Let's take a look at the list of families. So here's the list of lighting fixture families that's in the project browser. You may notice that this list seems to be a lot shorter than the other lists. I assure you it's not because it's any less comprehensive. Rather, in our latest release, we were able to consolidate lots of lighting fixtures into fewer families in order to both increase flexibility and simplify library management for everyone. And I'll show you what I mean. Well, I'll just real quick. I think there's about 25 lighting fixture families here that are actually used in the project, but there's nearly 100 lighting fixture types pre-configured, and each of those fixture types represent a different type of fixture. It's not just, you know, different types of 1x4s or different types of can lights. They're all different types of fixtures that these 25 families can represent. And I'll show you what I mean. I'll show you, this will be a good place to look at our we want to go to ceiling plan symbols and our test elements view. And I'll need to change my design option here. I don't need to sync. Yeah, this is what we call our test elements view. This is a view that we have under our working category that has one instance of each and every family type in the project placed, both for testing so that we can do testing, but also for you guys to get in here and take a look at what's in the project. It's just a view that has everything. We have views set up. We have a test element view set up for all of these under symbol working. Yeah, so we have similar views set up for pretty much everything, for you to get in here in the sample project and actually see what's here. This is the lighting test element view. So I'll show you lighting in here since they're all here and easy to get to. I'll show you what I mean about flexibility. These generally rectangular shaped families, if I select them, you'll notice that they're all the same family. We call that the rectangular ceiling floor family. There's multiple types selected. You see, we have all of these different types set up, but this is all the same family. Let's take a look at these in 3D, and we can take a look at the flexibility that this one family can do. Let me change this, change the hidden line so we can see a little bit better. Right. So with this one family, we can have your length, your width, and your depth is adjustable. Whether it is recessed or surface mounted is adjustable. So here's a recessed light, but there's a surface mounted light that's the same size. You can have it semi-recessed. This is a semi-recessed fixture. You can see it's above and below the ceiling. You can have suspended fixtures. The quantity and size of these stems is adjustable in each fixture. This represents like a strip light here. This would be a high bay light on a cord. So that's an example of the flexibility that this one family offers you, and you can hopefully see the advantage in that you don't have to rely on downloading manufacturer families. If you've worked in Revit, when you download manufacturer families, you always have problems getting them to show up in schedules properly because they don't have your parameters in them, and they just don't always work seamlessly. In fact, they usually don't work seamlessly. So instead of doing that, you can just configure these to be the general shape that you need, shape and size that you need, and it will represent the manufacturer families perfectly well. Not only is the geometry flexible, but the symbols are also flexible. You see all these are the same family, but they've got different symbols. We've got the TIE fighter symbol for strip lights. We've got a wall wash light. So all these symbols are optional. Also, see, my temporary view is on, so let's go find, let's turn on light sources. All of these families have built-in light sources. These light sources, you can, when you create a new fixture type, you can download the IES file for the particular fixture that you're creating, and you can load it into this family. And not only can you load it into the family, but you can reposition it and reorient it the way that you need it to appear. So this is one that sometimes takes a sort of a funny shaped direct indirect photometric web. Sometimes an IES file, a photometric web like that might need a little bit of finagling to get it to look right, to get it to be the way it needs to be. And there are features in each one of these fixtures that will allow you to move that light source around on the fixture and also change the direction that they're aimed. These light sources work using Revit's built-in photometric analysis. I told you that we have some stuff set up already for that. And they also work using third-party add-ins like Illum Tools. Illum Tools is an add-in from the folks that make AGI 32. They work with all their rendering stuff and they calculate accurately. So another feature that you're going to find in lighting fixtures is the ability to place them hosted or unhosted. I'm going to use a wall-based fixture to demonstrate that. And I'm going to change my discipline so I can select the wall. Let's do coordination. Yeah. So this fixture is hosted to this wall. And I can tell because I can't, if I try to move it, I can't move the fixture away from the wall. If I move the wall, all the fixtures move along with it. That's the way most families work within Revit. But a lot of people don't like that for various reasons. A lot of people don't like that other disciplines can move things that they have placed. They would rather just move it themselves. Also, sometimes you're working with clients that are working in AutoCAD. If you have an architect working in AutoCAD, or if you're doing a civil project, they're going to give you an AutoCAD plan. You don't have walls to host to. So we have unhosted fixtures. So these guys look like they're on the wall, but I can select the wall and move it out of the way, and they stay behind. And you can see that I can rotate these fixtures any which way. And what is particularly cool now is that these two are the exact same fixture. So if you look here in the properties, if you know what you're looking at in Revit, this is the same family with the same type, and one is placed hosted to the wall and one is not. So rather than having to pick for your firm whether you're going to do all hosted or all unhosted, or trying to maintain two separate family libraries of hosted and unhosted content, we have developed a way to get both hosting and not, unhosted content within the same family. So we were really excited we were able to do that, and we think that it's a great feature that we're excited to show off. Other than that, for lighting, we got a ton here for lighting. We've got directional cones. There's ceiling mounted bug eyes and exit signs. This round fixture is pretty much the same as the rectangular fixture, except it's round instead of rectangular.
Stephen.
Track light. Yes, sir.
There was a question that came in that I think you might be best suited to answer. And the question, since you just recently had gone through these lighting fixtures, I figured this might be meaningful. The question was surrounding how do we handle circuitry of emergency, critical, and standard circuiting?
They're just circuited to, well, if you've got separate circuits, then you would just create separate circuits. If you need to have multiple circuits going to an individual light fixture, so if you have both, if you have like a generator transfer device within a fixture, so that one fixture, that one circuit can switch between normal and emergency or critical or whatever branch you're working with, you would have to place like a separate family on the fixture. And I don't know if there's a workflow in the user manual to do that, but it is possible with a little bit of creativity. And see, Revit can't handle ATS type functions natively, and so you have to use workarounds that have pros and cons. So hope that answers the question. If it doesn't, you can come back and I'll keep going. we have a method of doing track lighting in the project, and the track light will calculate according to the requirements of the NEC. So in the NEC, track lighting is track lighting load is calculated based on the length of the track, not based on the number of heads attached to it. As I'm sure you know, it's the length of the track, or you can put a current limiter on it, and it's the rating or setting of the current limiter. So we have a method of doing that in the pack that I've not seen any method of doing that in Revit otherwise. We're really excited about our linear fixtures we were able to introduce. Lots of fixtures are specified based on the length of the fixture rather than the quantity of the fixture. And if you've ever used linear fixtures in Revit, if you need lots of different lengths, you might in the past have created different types for each individual length that you needed, but then you have to figure out how am I going to show that in my fixture schedule? I've got 6 different types because I need 6 different lengths. I don't want to show all that in my fixture schedule. Well, we have developed a method of actually adjusting these on a per instance basis. So this is a linear fixture. And for example, our apparent power here is 60.8 VA, but I can just grab this grip and adjust it, and you're going to see that my power adjusts properly. So if there's an example over here, I'll switch back to my sample project. So like all of these guys here, these 6 or 7 instances are all the same family and the same type, but they're all different lengths. The load calculates properly. They populate the fixture schedule accurately based on watts per square foot instead of total watts, and the light sources work. So if you're doing any kind of photometric analysis in here, we have a method of duplicating the light sources along the length of this that actually works properly. What else do we have? Wall-mounted bug eyes and exit signs, wall-mounted lighting fixtures. If I go to test elements, this is all the same family here. And we have options to be able to choose a round or a rectangular. And then we have site lighting. So we have a method of doing poles and pole lights. Let's go to our site lighting plan, or our site power plan. So here we have site lighting, and notice we have different types of lights on this one pole. This is actually a floodlight. Our floodlights are adjustable, so you can actually show it to be adjusted. If you're doing photometric analysis, you can actually aim it to where it's supposed to be. Same thing for our light heads. This is like a post top light. This would be like a Cobra head. So we have fully featured site lighting in here. That's a bollard. In fact, the bollard light is just that round ceiling floor light. So these round fixtures here, the bollard is just a reconfigured version of that. So it's not even a separate family. So so that's lighting. I think that is that's sort of an overview. We're getting close to time, and I can take more questions if we want, if anybody has any more specific questions. But that's pretty much all I wanted to cover as for an overview of the overall project, as well as some specific features. We hope you like what we've done, and I hope that you find it valuable for your firm.